Hi there. We want to show how you can use the GMM to analyze your data and the conditions that could bring about the use of the GMM. Now, when and how is GMM used for research data analysis? What's GMM? GMM is the acronym for Generalized Method of Moments. It is a statistical technique used in research data analysis to estimate parameters in econometrics and other statistical models. Here are some scenarios where it is appropriate to use GMM for analyzing research data. The first one is the model specification. GMM is useful when the researcher has a theoretical model with moment conditions that can be used to estimate model parameters. It allows for flexibility in specifying the moments based on the underlying theory. The second scenario is dealing with endogeneity. GMM is commonly used to address endogeneity issues in econometric models where variables are correlated with the error term. By using instrumental variables and moment conditions, GMM can provide consistent estimate in the presence of endogeneity. Now, the third scenario where we use GMM is efficiency. GMM can be more efficient than other estimation techniques when the model is correctly specified. That is emphasized that when the model is correctly specified. It provides estimates that are asymptotically efficient under certain conditions. Then the fourth scenario is handling missing data. This is a very important one. GMM can handle missing data by incorporating all available moments in the estimation process, making it robust in situations where data may be incomplete. So please let that be in your mind. Now, the fifth one and the last one is overcoming heteroscedasticity. GMM is robust to heteroscedasticity in the data, allowing for consistent parameter estimates, even when variances differ across observations. Now, this is the only econometric model that kind of try to take into consideration all the deficiencies that others don't have. So this is the reason why people use the GMM. So in summary, GMM is the most appropriate in scenarios involving endogeneity, efficiency considerations, missing data, and heteroscedasticity. That is the reason why some researchers prefer to use the GMM rather than subject their datasets to pre-estimation tests, which might lead them to adjusting or removing some of the important predictor variables crucial to the essence of the whole research data analysis. Now, you often hear some commentators saying that once your adjusted R squared is too low, then you have to remove some of the variables, or look for the variable that is causing it and remove it. Now, the important thing to note here is that if all the variables are important to your analysis, why remove any of them? That some of them causes the R squared to be very small means that there is something maybe as a result of many variables. But sometimes your analysis needs to include as many variables as possible, and you don't need to remove anyone simply because the R squared or adjusted R squared is very small. So, in other words, the GMM analysis kind of takes into consideration such scenarios and put to rest some of those arguments. Now, the GMM analysis with VSP. Now, let's consider uses of the GMM to analyze the DTGI dataset. The DTGI dataset analysis tries to find relationship between the MISR, that is market induced survival ratio, as the dependent variable, and the predictors proxied by DTGI, which is a disruptive technologies gains index, and then GCI, then going concern index, then RSR as Eni's relative solvency ratio, and then ZSC, which is Altman's Z-score, then CRAT, which is a current ratio, and then M, which is a markup ratio, and OBEP, which is a operational break-even point. So the Excel dataset file is displayed below. Now this is just the Excel dataset file. This is how it is. Now you can see, as before, all the columns labeled A to I houses each of the variables. Column A is the identity of each of the observed entities. In this case, we're just using industry 01, industry 202 instead of the names of the company. And then column B is for the MISR, that is the dependent variable now. And then the column C is for GCI, D is for CRAT, E is for Z-score, and the F is for RSR, while G is for DTGI, and then M is for H is for OBEP, and the I is for M. Now let us now see. Okay, the dataset contains 74 records observation, but only the first 15 were shown here. We will now use the dataset to do our GMM analysis with VSP. Now let us now call up VSP and see. Now this is VSP. Okay, let us minimize this so that we can see again good. So now this is the VSP environment. Now we go to the site data analysis menu, and then we call up the GMM, which is this Generalized Method of Moments. We call it up and wait for the definition form to come out. Now this has been modified from the console to form. The first version was you enter your data for GMM from the console, but now this is we enter now from that using the form, which will be displayed very shortly. I think the form is still initializing. It will soon bring itself up. Still initializing. Yeah, has arrived. So now we start entering the data. Our dependent variable here is MISR. And then we now go to other ones. We have, I think, DTGI, comma, no space, GCI, comma, no space, RSR, comma, no space, OBEP, comma, no space. Then we have CRAT, comma, and no space. Then we have ZSC. I think that is all. Okay, see remaining one. And that last one is M. So and then we now take it to where we have the dataset file. Now the dataset file is named DTGI. So we simply just write DTGI. And then whether it is in uppercase or lowercase doesn't really matter. It will bring it out. The only one that discriminates, like I've always been saying it, is the names of the variables. If you use uppercase for variables, you must use it in this form. If you use lowercase, you must use it in this form. But if you use uppercase and decide to use lowercase here, then it will generate error. So, but here in the file name, you can use uppercase or lowercase, and it will still process it for you. So, having done that, we simply just click process data, and it has just finished very fast. Now let us see the results. Yeah, so as before, this is the results. Now the value start statistical package output, then started with the GMM pre-estimation test results. Yeah, even though GMM does not really need a pre-estimation, but we decided to include it in VSP so that you can also compare. Now, this is the pre-estimation results showing everything that we have been able to do here. You can see. And the correlation matrix is also there. And then the variance inflation factor. And of course, we have the Dubbin-Watson test for serial correlation. It's also there. And I think it's moderately correlated. And then this is now the GMM test results. The GMM test results. Reading from it, we have the dependent variable as MISR, then the estimator is IV GMM. The number of observations is 73, and then the covariance estimator is robust, and the R squared is 0.0776, while the adjusted R squared is minus 0.0218. Now, in this type of case, what they normally do, that so what some commentators will do is to say, okay, since you have a minus adjusted R square, you have to remove some of the parameters, some of the variables, so that you can come up with a reasonable R squared and adjusted R squared. But in the real sense of it, everything we have used here is every variable is very essential for that particular dependent variable, so to predict it. So that is the reason why it has to be there, and that is the reason why this GMM was introduced in the first place. Now, other statistics, the F statistics is 15.564, and the P value is 0.02, which is very significant. So you can see how significant it means that the MSIR is that the model is fit. The model is fit, despite the fact that the adjusted R squared is giving a minus, but the F statistics is showing us that the model is fit. And then the distribution is the chi-square, which is 7 degrees of freedom. Now look at the parameter estimates. The parameter estimates here showing the here the intercept. Intercept is not significant. Well, you also have the lower confidence and upper confidence intervals. And we'll look at other one, look at the T. Then the one that are significant here, I think the only one that is significant, and that one is the operational break-even point, OBEP. That's the only one that is significant. All others are not significant in this relationship. So the operational break-even point is significant to market-induced significant to the market-induced survival rate, market-induced survival rate of companies. So operational break-even point is significant to it. It means that, you know, operational break-even point is something that must be pursued by every organization to ensure that they have an acceptable operational break-even point. I think that is one of the work that researchers in business and accounting and finance should look into. That is the operational break-even point by NE and then plus others. Now, it's part of the discriminant analysis process. That's the operational break-even point. It's part of the discriminant analysis process. Now, you can see after the GMM, the parameter estimates, there are some two warnings here which are not fatal anyway. Telling us that user warning figure canvassing is non-interactive and thus cannot be shown, and the same thing for the other one. So it's one of those, maybe some of the data actually caused that, but the truth is that everything has been done the way it's supposed to be done. So that is about the GMM, when you are supposed to use it, why you are supposed to use it, and how you can actually use it, you know, with the VSP statistical package. Thank you for watching.